Hello everyone. Welcome back to Dr. Lou's VCE Science channel. Today, let's learn together about the 2022 chemistry examination. We will focus on questions related to electrochemistry. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Fuel cells are one type of galvanic cells, which convert chemical energy into electrical energy. The load is connected to the fuel cell, and the power source is not necessary for fuel cells. So, B and C are ruled out. Oxygen in air gains electrons and plays an oxidant, so, the air side is cathode. Finally, D is ruled out and A is the only correct answer. Both galvanic cells and fuel convert chemical energy to electrical energy. So, C and D are ruled out. Both galvanic cells and fuel are not reversible. So, A is ruled out. Heat energy is a byproduct of any cell, although the production of electrical energy is the main function of batteries. If the fuel can be added to fuel cells continuously, fuel cells can run continuously. However, adding fuel does not charge cells. So, the fuel cell cannot be recharged, and A is ruled out first. If carbon fuel is used in fuel cells, oxygen in fuel cells oxidizes carbon fuel into carbon dioxide, which is a greenhouse gas. So, B is also ruled out. Generally, fuel cells are not activated by electrical energy. Fuel cells overcome the activation energy barrier by two methods: catalysts lowering the activation energy barrier and increasing the kinetic energy of reactants in fuel cells. To produce the electric energy, the oxidant and reductant must be separated in any cells, otherwise, cells produce heat energy instead of electric energy. So, D is correct. Since PT is an inert metal, PT is not involved in electrolysis reactions. This question is focused on the production of gas at the cathode. Gaining electrode, reduction, occurs on the cathode. So, gas at the cathode is produced by the oxidant. In the molten salts, there is no water. The metal ions are oxidant at the cathode to produce molten metals. The products of molten sodium chloride and lead bromide are molten sodium and lead metal, not gas. So, B and C are ruled out. In the aqueous solution, water could be reduced or oxidized. Copper ion is a stronger oxidant than water, so, copper ion gain electrons first to produce copper metal in cathode instead of gas, and D is ruled out. However, water is stronger than potassium ions, so, water gains electrons first to produce hydrogen gas, and A is correct. Please read all questions first. In the multiple choice, there are four substances: hydrogen ion, water, oxovanadium-4, and oxovanadium-5 cation. The question is related to whether they are a reducing agent or an oxidizing agent. The reaction is supposed to be recharging, which is the reverse of discharging. All the electrochemical reactions are redox reactions no matter how discharging or recharging. If water or hydrogen is involved in redox, oxygen or hydrogen gas should be produced. Here, oxygen or hydrogen gas are not involved. So, hydrogen ions in water are not reduced or oxidized, and A and B are eliminated first. In the discharge reaction, oxovanadium-5 ions gain electrons as oxidants. In the recharge reaction, oxovanadium-4 ions lose electrons as reductants. So, C is correct, and D is wrong. Any half cell must be composed of a redox conjugate pair. The tin ion, 4, tin ion, 2, is composed of tin ion, 4, and tin ion, 2, only. So, A is eliminated because tin ion, 4, is not contained in the solution. Although B contains both ion, 4, and tin ion 2, tin metal also exists in B solution. Therefore, there are other redox conjugate pairs in B solution: tin metal/tin ion, 4, and tin metal/tin ion, 2. So, B is eliminated. In C solution, tin ion, 4, and tin ion 2 exist only and no other ions, compose redox conjugate pairs only, tin ion, 4/tin ion 2. So, C is correct. In the D solution, only tin ion, 4, exists, and it can't lose electrons further to form tin ion, 2. So, redox conjugate pairs are not formed in D solution and D is wrong. However, sliver ions plus inertia electrode without sliver metal is working because sliver ions can gain electrons from sliver metal. Furthermore, silver ion and sliver metal composed redox conjugate pairs. Yes, the strongest oxidizing agent present is cobalt ion and the strongest reducing agent is zinc metal, but they mix and do not produce electrical energy. However, the chemical energy is converted to heat energy. So, A and D are eliminated, and B is correct. Although zinc metal loses electrons to increase the concentration of zinc ions, cobalt ions gain electrons to decrease the concentration of cobalt ions simultaneously. Therefore, the concentration of all ions is constant. So, C is eliminated. Reduction always occurs in the anode and oxidation in the cathode, whether during discharge or recharge. During discharge, lithium metal loses electrons in the anode, classified as oxidation. So, A and C are eliminated. During recharge, lithium ions gain electrons in the cathode, classified as reduction. So, B is eliminated, and D is correct. During discharge, the Lic6 loses electrons to produce Liq6 in the anode, classified as oxidation. During recharge, the Liq6 loses electrons to produce Lic6 in anode, classified as oxidation. During recharge, the anode must be connected to the positive electrode of power and cathode negative because the positive charge of power pumps out of electrons in the anode and the negative charge of power pumps electrons into the cathode. So, A is eliminated first. During discharge, the electrons move to the positive electrode through external circuits, and positive ions move towards the positive through the internal circuit of batteries. B is correct. Raising the battery temperature increases the rate of reaction to accelerate the consumption of reactants, so it shortens the battery life, and C is wrong. During discharge, chemical energy is converted into electrical energy, which is a galvanic cell. On the other hand, during recharge, electrical energy is converted into chemical energy. So, D is wrong. Since I2 is a reducing agent, the result that I2 reacts with Bro3 and Bro but not with Cro4- means that the reducing the potential of IO3 is lower than that of Bro3 and Bro, but higher than that of Cro4. Since Br is a reducing agent, the result that Br- reacts with Bro but not with IO3- means that the reducing potential of Bro is higher than that of Bro3 and IO3. So, the order of potential is, from highest to lowest, Bro/Br2, Bro3/Br, IO3/I2, Cro4/Cr3+. The cell producing the highest potential difference will be the cell containing the strongest oxidizing agent, Broag, and the strongest reducing agent, Cr3+, and A is correct. Step by step. First, calculate the amount of carbon dioxide released, and then the pressure of it. The volume of gas is equal to that of the container. Here, the volume of the tank is 20 kL, so the volume of carbon dioxide is 20 kL. Using the gas universal equation, we should adjust the units of measurement to mole, K, L, and K, Pa. The significant figure of the answer is 3 because the minimum significant number is 3. An electrolysis cell is used to generate hydrogen gas from water molecules. Since the oxidation number of hydrogen in water is positive, electrons must be received to become hydrogen gas. Electrons must be pumped into the cathode and a downward arrow should be drawn in the box. 2 marks cover 2 functions. The membrane should allow hydrogen ions to pass through to balance the charge between the anode and cathode. Also, oxygen gas and hydrogen gas should be separated to prevent them from regenerating water. A membrane is used to separate them. The overall equation is the equation of electrolysis of water, no matter how the electrolyte is used. Step by step calculate the amount of hydrogen gas. 3 marks cover 3 steps. First, calculate the charge used, then, the mole of electrons, and finally, the mole of hydrogen gas. Please write the answer step by step, not miss any step. Please convert all units of measurement to SI units. The significant figure is 3 because the minimum significant figure is 3. Thermochemical equations include chemical equations in changed enthalpy. 1 mark was awarded for a correctly balanced equation with correct states. The second mark was awarded for showing correct delta H and Kj mole -1, including signs and units. 2 marks cover 2 steps. First, calculate the mass of LPG, and then, the energy released. Please convert the units of measurement to SI units. Please take care of K and M. K is thousands, and M is million. Please use scientific notation, not write many zero numbers. The significant figure of the final answer is 3. Oxygen gas receives electrons as an oxidant, and electrons run into electrode P. So, the positive charge should accumulate in the electrode to attract negative electrons, classified as positive electrode. In electrode Q, one propane molecule loses 20 electrons. To balance the negative charge, 20 positive hydrogen ions are added on the right side of the equation because this reaction occurs in an acidic electrolyte. Reactants can be supplied into fuel cells, whereas they are stored in secondary cells once and cannot be added after secondary cells are produced. Products move out of the fuel cells, whereas in a secondary cell, the products remain in contact with the electrodes. The fuel cells produce greenhouse gases, whereas the secondary cell does not. There are 10 multiple-choice questions worth 1 point each, totaling marks. There are also 2 short-answer questions worth a total of 18 marks in this section covering electrochemistry. The overall score for this section is 28 points. With a total possible score of 120 points, the percentage for this section is 23.3% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Chemistry channel.